Hello, welcome back to my channel MedMind by Wires. Today, our topic is hemoglobin and blood indices. We need to know how is this hemoglobin even synthesized at the first place. Now, you see succinyl coenzyme A. This is one of the substrates present in the TCA cycle. This tends to combine with glycine in the presence of ALA synthase, forming ALA. Now, what is ALA? ALA is delta amino levulinic acid. All right. Now, this ALA synthase, after forming ALA in the presence of ALA dehydrogenase, undergoes many steps. This dotted arrow over here shows different steps. So I have skipped all of them, finally forming porphobilinogen. This porphobilinogen tends to form protoporphyrin 9. I know this sounds like Greek and Latin to you, but then just letting you know, you just have to know the steps, and the detail of these steps will be explained in biochemistry under heme metabolism. So right now, we know that porphobilinogen to protoporphyrin 9. Now, this protoporphyrin 9 in the presence of heme synthase, which is having ferrous ion as a part of it, is going to form heme. Now, heme later combines with globulin, which is formed from the ribosomes. They are finally going to form hemoglobin. So, voila, we have finally invented hemoglobin. Now, do you think we're done with the chapter? Well, no, this is just the start. Now, over here, you see there is something called as types of hemoglobin, right? Now, what are the types of hemoglobin? Obviously, there's going to be normal hemoglobin, and obviously, there's going to be abnormal hemoglobins, right? Because there has never been a time in our lifetime where life was just talking about normal. Now, what do we know about normal hemoglobins? This is the one that you and I have. If we don't have this, that means we have one of these following disorders, which we will talk about later. In adult hemoglobin, the adult hemoglobin is mainly divided into two types, HbA and HbA2. Then fetal hemoglobin. Fetal hemoglobin is like the kids who exist out there. So they have HbF and HB Bart's hemoglobin. Now, what am I talking about? Now, you know that hemoglobin is present in our body. Now, there are different types of hemoglobins, and that is adult hemoglobin that is present in you and me, fetal hemoglobin, the one that is present in fetus, the embryonic hemoglobin that is present in the embryo. Now, embryonic hemoglobin. Now, embryonic hemoglobin is HB Gover 1, HB Gover 2, and HB Portland. Now, what are these weird names? Why is the embryo named after that? Now, Gover 1 and Gover 2, that is Gover, it is especially from an island. Okay, so Gover has been named after an island, and such, discovery of the embryonic hemoglobin was done in such island, that is Gover, hence the names. Then what is Portland named over here? Portland is also, the embryonic hemoglobin was found in Portland, which is in England, and hence the name HB Portland. Now, we will talk about the abnormal hemoglobins. Now, abnormal hemoglobins, if you find hemoglobin S, C, D, E in your blood picture, it is very much abnormal. We do not want to have such type of blood reports, do we? Now, HbS is present in what type? S stands for sickle. So, sickle cell anemia. People who have sickle cell anemia will have hemoglobin S and not any of these. Okay. Now, HbC is present in HbC disease, D is present in D disease, E is present in E disease, which, like, we do not want to talk about it in detail right now. Now, next thing over here is the unstable hemoglobin. This type of hemoglobin is Tedamida. This type of hemoglobin has no stability in life, just existing, going on around. Now, such type of hemoglobins are mainly found when the beta chain is affected. We know that we have alpha chain as well as the beta chain. Now, among these two chains, when the beta chain is mainly affected, that is when you will have an unstable hemoglobin produced. The adult hemoglobins. Adult hemoglobins has HbA. Now, this HbA and HbA2, which is there. HbA comprises the majority of the adult hemoglobin. It is almost up to 97% of the entire hemoglobin that is present. So, HbA comprises 97% of the adult hemoglobin. Now, the composition of this HbA, like what is it made up of? It is made up of 2 alpha units and 2 beta units, hence alpha 2, beta 2. Now, what are these two? These are just like the chains that are present, the alpha chains and the beta chains that we know about. Now, HbA tends to replace HbF. HbF is mainly found in the fetal hemoglobin. That is when you and I are just fetuses. We are just existing in life, doing nothing, having no tension and no headache. Now, when our hemoglobin is HbF type, that is when we were fetus, eventually HbA is like you are done with your break, time for you to grow up and time for you to start taking tension in life. That is within the first few months of the postnatal life. HbF will eventually become HbA. And then HbA is fully established in the 6 months of life where the torture of life starts to begin. Okay, now HbA2. If HbA of the adult hemoglobin comprises 97%, then HbA2 of the adult hemoglobin comprises 3% of the total Hb. Now, if HbA is comprised of alpha 2 beta 2, this is comprised of alpha 2 and delta 2 chains. Now, the concentration of HbA2 tends to increase in some amount or some types of anemias. Fetal hemoglobin, that is when you and I are just kids, we're just having fun in life. Now, this HbF is having two alpha chains and two gamma chains. All right, I get it. These are pretty tough to memorize, but remember, repeat after me. HbA is alpha to beta 2, HbA2 is alpha to delta 2, and HbF is alpha to gamma 2. And this HbF comprises the major hemoglobin of the fetal hemoglobins, obviously, because FF, yaad rakh lo. Then, major type of hemoglobin. Originally, it comprises 70 to 90% of the fetal hemoglobin, that is HbF. Later, it decreases to as low as 25% in 1 month and to as low as 5% in 6 months, which is eventually replaced by the adult hemoglobin HbA. Okay, so 25% in 1 month and 5% in 6 months. In adults, 1% of hemoglobin A is not reached in some children. Like some children do not completely get converted into HbA. They only get converted into HbA once they hit puberty, not within the 6 months. So they only hit the HbA value when they reach puberty. So this 5% present in the 6 months, if they have to get converted to 1% of hemoglobin. So what am I trying to say? Now, in 5% of hemoglobin F will be present. Only 5% of hemoglobin F will be present in the 6 months after postnatal life, right? Now, for this 5% to reduce to 1%, so that there's only 1% of HbF remaining. Why? Because more amount of HbF, that means we did not grow. We're still fetuses. We have to have more amount of HbA. So, when you become an adult, you should have more amount of HbA. You should not be having more amount of HbF. For this 5% HbF to get converted into 1% HbF, this conversion takes place very quick. But in some children, they will be only reached when they hit puberty. Okay? So this is the child, and once she has hit puberty, now she has final value of only 1% HbF. Now, another type of fetal hemoglobin is HB bars, which has only 4 gamma chains. No alpha, no beta, no nothing, just 4 gamma chain, and increases in concentration in fetuses who have thalassemia. To embryonic hemoglobin. Embryonic hemoglobins are obviously going to be present in the embryos, and they are divided into Goa 1, Goa 2, and Portland. So HB Goa 1, it is from the Goa Peninsula. It was found there, and hence the name Goa. And this has 2 zeta plus 2 epsilon. This is what it's comprised of, like how HbA is comprised of alpha beta chains. This has zeta chain and the epsilon chain. Now, why such Greek names? Why is it making our life so complicated? Now, simple. Now, Dick, look at this. Zeta. What does zeta mean? The zeta is like early alpha like chain. And what does epsilon mean? Early beta like chain. So you can think that this HB Gower 1 is eventually going to go and get converted into alpha chains, beta chains, which is resembling the HbA comprising 97% of the total hemoglobin. Now, Gower 2 is again 2 alpha. Eventually, this gets converted into alpha and 2 epsilon. This remains primitive as such. You can remember it like that. Now, HB Portland, likewise, I said, it has been found in Portland, which is present in England. So, 2 zeta plus 2 gamma. Now, gamma is something that is present in fetus, which is true. Eventually, this gets converted into the fetal hemoglobin. Unstable hemoglobin. Now, what is this unstable hemoglobin? Now, hemoglobin tends to undergo denaturation and then later gets precipitated to form something called as the Heinz bodies. Okay, when such type of process happens, okay, it is very bad. And when you see certain unstable hemoglobins, they are mainly present in congenital non-spirocytic anemia. So anemia may have, but then it is not spirocytic and it is congenitally present. Such is the unstable hemoglobin. Normal values. Now, in adult males, they have 14 to 18 gram per deciliter, and females have 12 to 16 gram per deciliter. Why? Because estrogen is an inhibiting hormone, whereas testosterone is a promoting hormone. Therefore, males have a higher HB value compared to the females. Now, newborns will have 16 to 22 gram per deciliter. The clue of this answer, why newborns have higher than males and females, that is basically adults, is in the previous video. Functions of hemoglobin. Now, functions of hemoglobin, is it to maintain life? Is it to ensure? It is, the function of the hemoglobin is to ensure that you and I don't die. We survive the hit. Well, no, that's not what exactly its functions are. Its functions are, first, gas transport, exchange of oxygen and carbon dioxide. Oxygen through oxyhemoglobin, carbon dioxide to carbaminohemoglobin. Okay, it helps in the exchange of them. Now, there is this simple math that you have to get to know. Yes, I know we all might not like math. So saturated hemoglobin, that is, let's say 1 gram of hemoglobin, there is a small amount of gram. This gram of hemoglobin, let's say it is completely saturated. A saturated 1 gram of hemoglobin would approximately contain 1.34 ml of oxygen. Now let's say that we have taken a male ka hemoglobin value which says 15 gram percent, because it is a normal range, right? The normal range is 14 to 18, and let's say that we have found his value to be 15. So how much will you know is how would you calculate the amount of oxygen his blood is carrying? So if 1 gram contains 1.34 ml of oxygen, then 15 would take, through this cross multiplication you can find out that it would take about 20.7 ml of oxygen. So this is one example. Now over here, next is the buffering function of hemoglobin. This buffering function is to enable and help maintain the pH of the hemoglobin. Now, this is like the hamburger's phenomenon or the chloride shift that you see, where carbon dioxide and water in the presence of carbonic anhydrase gets converted into carbonic acid in the presence of Ca, again finally converts into bicarbonate and H plus. Now these two, okay, is responsible for the pH maintenance of the hemoglobin. Now, what is this arrow out and what is this arrow in? Every bicarbonate ion that tends to go outside causes an influx of chloride ion, hence the name chloride shift. Okay, now the third function of hemoglobin is that it imparts zero color to our body. That is why all of us are pale. Well, no, that's wrong. It imparts red color to the hemoglobin. It acts as a red pigment, and that is why you see your RBCs are red. If you see that your RBCs are not red, high time to think whether do you even have hemoglobin in your body. Over here, let's go into first clinical. Now HB destruction, that is hemolysis. When hemolysis means breakdown of HB, hemoglobin. So hemoglobin, when it is undergoing hemolysis, would form heme and globin. Now this globin is a good one, like a good kid, is going to get reutilized and help in the further formation of hemoglobin again. It's going to help, it's going to not go waste, it's going to form as one of the substrates to form more hemoglobin. But let's see what this heme is coming up to, is what this heme is showing. This heme, in the presence of heme oxidase, will get converted into biliverdin. Biliverdin, in the presence of biliverdin reductase, will get converted into bilirubin. These are all the bile pigments that are present and that exist. Now, there is something called as acute hemolysis. Now, acute hemolysis is where there is sudden breakdown of the RBC, causing a sudden decrease in the hemoglobin value. Okay, resulting in the formation of HB Cas later. Now, let's say there is acute hemolysis, which is a sudden reduction in simple, which is like a sudden reduction in the HB value because of breakdown of RBCs, which is very sudden. This forms HB Cas. Now, HB Cas is related to Tom Horsfall protein, which what's going to happen is when this HB Cas, how are they even formed? Now, when there is sudden breakdown of HB, what's going to happen is that they are going to get precipitated or filtered mainly by the renal tubules. RT over here is the renal tubules. When they are get filtered by the renal tubules, they tend to later form high amount of free hemoglobin will be found in the blood. Now, this high amount of free hemoglobin that is present would later go and not sit free. It's not going to mind its own work. It has to interact with our system. So it goes and combines with something called as Tom Horsfall proteins. So it goes and combines with this, resulting in the formation of HB Cas that tends to block the renal tubules. Now, once the renal tubules are blocked because of these HB Casts, it's going to form necrosis. Matlab, you and I, our renal tubules are officially dead. They have given up on us. So another leading clinical related to the same thing is acute renal failure and tissue hypoxia. Now, hemolysis causes where the hemoglobin is released into the blood, especially, and this released hemoglobin enters into the renal tubules, which is later excreted in the urine, and such a condition is known as hemoglobinuria. Urea, urine. Hemoglobin, that is hemoglobin in the urine. Hemoglobinuria. Now, this HB Cas, which are formed, blocks the lumen of the tubules, that is the renal tubules, causing tubular necrosis or acute renal failure. Now, why did I write deficiency of HB? Now, what do you mean by acute hemolysis? Sudden breakdown of hemolysis causing a huge decrease in the value of hemoglobin in the blood. So, that is nothing but deficiency of hemoglobin. Deficiency of hemoglobin, and one of the functions of hemoglobin, like we studied before, is the transport of oxygen. Deficiency of hemoglobin means no transport of oxygen. No transport of oxygen means no amount of adequate oxygen reaching to the tissue. No amount of adequate oxygen reaching the tissue means it leads to a hypoxic condition. Hypoxia is a condition where there is no adequate amount of oxygen. All right. glycolated hemoglobin, that is HbA1c. This glycolated hemoglobin is mainly very important. We use this, it is a type of a test which helps to find out prolonged hyperglycemia, whether a person has high amount of glucose, okay, in the plasma. So when we have to know how long has glucose been in the plasma, the test we conduct is glycolated hemoglobin, that is HbA1c. Okay, it tends to detect chronic diabetes or severe diabetics. Now, according to American Diabetic Association, that is ADA, if the HbA1c value is 4 to 5.6%, it is going to be normal. And if it is 5.7 to 6.5%, time for you to watch out. I think it's high time for pre-diabetic state. But if it is more than 6.5%, you have to start taking severe health precautions because you are diabetic. Now, where are you going to find this elevated HbA1c? Obviously, diabetes mellitus. DM is not direct message me. It means diabetes mellitus. Then it is also going to be elevated in hyperthyroidism. It is also going to be elevated in Cushing's syndrome. So these are the places where your HbA1c will be highly elevated.